Alright, so this is going to start our circles unit. This is 6.1. We're going to review some circle terms, and then we're going to get into some tangent properties. So let's review parts of a circle, how to name them, and certain terms. So starting off with congruent circles, you can see the two radii that are congruent, so that would be circle F and circle G. Okay. Concentric circles, we don't ever really name those, but that would be these right here. Okay, and so that would be circle H, and so to speak, circle H. Okay, the little one and the small one, the little one and the large one. The radius is a segment. Okay, so there's three radii that we can name: AC, and make sure you put the segment symbol on top. There's BC, and there's also EC. Okay, and so the symbols are key. We did this back in chapter 1, so this is a review. How to name a chord. A chord is a segment whose endpoints lie on the circle, so that would be ED. JI would also be one. And then also EB. EB is a segment whose endpoints lie on the circle. Okay? EB is a specific chord. It's actually the diameter, which that would be the longest chord in a circle. A tangent is a line that touches the circle at exactly one point, which that would be D, and we need one more point, so we'll just say K. Okay, so line KD is a tangent line. Okay, make sure you use the arrows because tangents are lines. A central angle, that would be angle ACB. This is where the vertex is at the center. And then there's another one, ACE. And that vertex is also at the center. The sides are always going to be radii. So speaking of central angles, that's 80 degrees. Its intercepted arc is also going to be 80 degrees. We learned that back in chapter 1, so I'm just going to refresh your memory. Minor arcs. Minor arc is an arc that is less than, that's a mistake, less than 180. So speaking of the arc that we just did, let's go ahead and do arc AB and make sure you put the arc symbol on top. Okay, there's many more. Okay, so I'm just going to name a few. BD is one. AJ is one. IE is one. And like I said, there's many more, but we're just going to go ahead and name 4. A major arc is an arc that is greater than 180, and you have to use 3 letters to name that. So ABE is a major arc. ABE. Okay. Some people would say ADE. You don't need to write that again because that's the exact same arc that we just did. So we're not going to write ADE. We can go the other way. We can start with B, and then we can say J, and then we can say D. B, J, D would be a major arc. Okay? And there's many, many more, but we're just going to name a couple. A semicircle is exactly half of a circle. So in this case, you want to focus on the diameter. So that would be E, A, B. That would be a semicircle. Okay? The other way around would be E, D, B. Those are 2 different semicircles, one on the left and one on the right. Next is an inscribed angle. An inscribed angle, we haven't really touched on this year, and we'll go over it again, but this is when the vertex is on the circle. So in this case, there's only one, and that would be DEB. Angle DEB, that is an inscribed angle. And then lastly, there's a secant, and that would be JI, and that is a line. So you want to make sure you put the line symbol on top of that. Okay, so these are all parts of a circle. There's names. You got to name them correctly. You'll have a section of this on your next quiz on Thursday. Some terminology. We've got a tangent circle. Okay, that's when 2 circles that are tangent to the same line at the same point. So for instance, in this picture right here, this yellow and this green circle, okay? Those two right there are tangent at this one point to that tangent line. Okay, so the green and the yellow circle would actually be externally tangent. Okay, so if I go ahead and name those circle A and circle B, that would be these right here. Okay, there's also another way they can be tangent, that would be internally tangent, sorry. And internally tangent, we have, say, a tangent line maybe about right there. This would be the point of tangency, and let's call that circle C. So circle B and circle C are externally tangent. Okay, so those are tangent circles, and you don't always have to see the tangent line there. Okay, the next one we have is a common tangent. This is when a line is tangent to two or more circles. So for instance, this is what I'm going to call line M. Line M is tangent to the red circle there and tangent to the green circle there. So it's tangent to two circles. Okay, this is on the outside of the circles. Okay, so you can say that line M would be an external common tangent. Okay, so this is an external common tangent. Okay, let's call this one over here line N. So this is line N, and this is tangent to the red circle at that point and tangent to the green circle at that point. And so this is kind of in between the two circles. So we're going to say this is an internal common tangent. Okay, so it can be internal or it can be an external common tangent. Okay, so those are some tangent vocabulary. Let's go to our first investigation. Okay, so we're going to construct a circle. Okay, and then after you construct the circle, it says to label it circle U. Okay, and then it says use a ruler to draw a line that appears to be tangent. So use your ruler. And then it says name that point of tangency T. Once you do that, get your ruler and connect U to T. And when you connect U to T, it says to go ahead and get your protractor and measure the angle. Okay, well, I think it might be pretty obvious what that measure is. Okay, mostly everybody can kind of tell. Okay, and it looks like it's right at 90, it's right on that line. Okay, and so that's the first conjecture that you're going to have to memorize. So this right here we need to mark. Let's mark it in red or a bright color. This right here is 90 degrees, okay, which forces that side to be 90. And so a tangent to a circle is perpendicular, don't forget the perpendicular symbol, to the radius drawn to the point of tangency. Okay, more importantly, if you connect this to any point on the tangent, you have yourself a right triangle. So be prepared to do Pythagorean theorem or trigonometry. Okay, so more importantly, how would you construct a tangent specifically? You can't just connect the ruler, touch the ruler to the side of a circle. So let me get my ruler. And then, so this will be just a little review on how you would construct a tangent, okay? So I'm going to let that be the center of my circle, okay? So you would use your compass to make a circle. Okay, and so to draw a perfect tangent, okay, what you want to do is draw a radius, but you don't want to stop right there. You want to kind of extend it outside the circle. And then you want to kind of recall how to construct a perpendicular right at this point, okay, that little point. So what you want to do next is you want to get your compass, place it on the blue point, and think back how to make a perpendicular. So you want to make a smiley face. That's terminology that I use, so you can try to remember it. And extend the compass, and let's make an arc way up here. And then put it on the other side over here where the circle touches that line, make another arc. And then now get your ruler and connect there. And so that should be on point a perpendicular. Okay, and that should be a nice, perfect 90-degree angle. Okay, so you need to construct it like this in order to make it a perfect tangent. Okay, you can't just assume the ruler touches the circle at one point. Okay, second conjecture. So let's construct a circle and label the center E. Okay, so with your compass and make a circle. Okay, this is going to be circle E. Okay, so let's pick a point outside the circle. Okay, call it N. And then it says to make two tangents that go from the circle through point N. So two tangents. Tangent can come from up here. Okay, and then it says to label the points of tangency A and G. Okay, and it says to compare the lengths of AG and lengths of AG and NG. So I'm going to place my compass on here, extend it to G, and then let's see how it compares to this right on the point. So that tells you right there that these two segments are identical. So let's go ahead and put some tick marks on here and say that those two are congruent, because they are. And that is always the case now. So this is the second conjecture you need to have memorized. Whenever you see two tangent segments, and they're tangent to one circle from one common point, so in this case it's N, outside the circle, then they are going to be congruent, always. Okay? So if I were to connect this point right here, this little point right here, and connect it to that tangent mark right there, well, guess what? These two little points right here, or segments I should say, are congruent, okay? Because of the same reason. They are joined by this point, and they're both tangent to the same circle. Okay, so memorize that conjecture. So let's utilize these into these problem examples. Okay, so looking for angle W, okay? In this case, it's going to be 50. Let me explain why it's going to be 50. You need to recall back that these are both 90. That's what we just learned today. And then more importantly, this you knew from a long time ago. A quadrilateral measures 360 degrees. Well, this is 90 and this is 90. That makes 180. That means this angle and this angle will always equal 180. So therefore, all four add up to 360. Okay? Don't forget that if this angle right here is 130, this arc is also 130. So I want you to write that down too. That's 130 degrees. Okay. Over here, This is an isosceles triangle based on the property we just went over, which makes these congruent because they're base angles. So subtract 180, that makes each one 70. Over here, you want to fill in that right angle. That's the property we just learned, the first one, which means you have a right triangle. So you want to do 5 squared plus 15 squared equals c squared, square root. That'll get you this whole side. Okay, that whole side, I believe, is 15.81. That's not our answer, though, because they only want SA. So you got to realize that that's 5 because all radii are congruent in a circle. Subtract 5, that'll leave you with 10.81. And lastly, how do I find segment W? Okay, well, you'll want to connect the point of tangency to the center, so that way you can work with a right angle. If this is 130, this angle here is also 130, which makes this one 50. So that's 50 degrees, that's 30, so you want to focus on this triangle. And then you want to use the 10 to help you out. This is 10 right here, that radius, because all radii are the same. So now focusing on that, we're going to use tangent because I know this is opposite and that's adjacent. So tangent of 50 degrees equals opposite over adjacent. Okay, cross multiply if you forget what to do. W times 1 is W, and then 10 times tangent of 50 degrees is going to be what W is. And I need to get my calculator so I can see what that measure is. Times tangent of 50, 11.918. And that'll be the length of W. Okay? So W always goes from the point of tangency to right there. All right? And that's it for today.